speaker will be Associate Professor Dr. Maya. She is the head of the Micropollutant Research Center at University Tun Hussein on Malaysia. So, Dr. Maya, the floor is yours. You can start.
Okay, thank you so much, Dr. Wissam. I'm sharing my slide here. Okay, shall we start now? I hope that everyone's hear my voice.
Yes, Doctor, yes, you can start.
Okay,
It's clear.
Okay, Assalamualaikum and good day, everyone. Good morning, good afternoon, good night, maybe, for everyone's, wherever you are. My name is Maya. I have very long name, but you can just call me Maya. I'm from University Tun Hussein on Malaysia. I'm really glad to be here with all of you. We have so many participants from different countries. So we have many perspectives, and I'm sharing with you what I have from my experience about the sustainable sanitation. After 1 hour, my colleague, Associate Professor Dr. Eslina, will share with you about solid waste sustainable. So my focus is on the sustainable sanitation. Okay, this is my university location in Malaysia. This is about the 15 kilometer from North-South Expressway. Unfortunately, because of the pandemic, we cannot, it's very difficult for all of you if you want to come and visit us, but hopefully one day, when the pandemic is over, you are welcome to visit us and we can do so much research or collaboration. So this is the location of the university, which is located at the south of Malaysia, near to Singapore. And then from Johor Bahru, it takes about 1.5 hours to arrive to our university. And this is our view. Sorry. And this is our university view. Yeah, as you can see, we have a very big lake. And I will show you also in this slide about our experience and sharing about the sanitation that we have done here in Malaysia. Okay, these are the topics on the sustainable sanitation. So I will discuss on the concept about the world sanitation scenario, the type of the wastewater, the contaminants. Okay, what's the difference between the centralized and also the decentralized wastewater treatment? And I will giving you the examples of the case study that covers on centralized and also the decentralized. Okay, mostly what happens in Malaysia and some the other countries as well, and also the conclusions. So I hope that this lecture and talk will give a benefit to all of you. Okay, so by the end of the lecture, I hope that you can understand the concept of the sustainable sanitation. You can distinguish or difference, compare between the centralized and decentralized wastewater treatment. And you know the current issues related to the sustainable sanitation, and you can understand the aspect needed to ensure the successful of the sustainable sanitation. Okay, first of all, what is the sustainable sanitation? So this is the system that can cover the aspect of sanitation which is affordable, cost-effective, that can give a benefit to the community and also the local authority for the long term. So usually people will say that sanitation, it will touch aspect of the personal and household hygiene, solid waste, greywater, or safe excreta disposal. So here it is, but it's actually more on the sanitation that can cover aspect on the health and also on the environment. So this is the facts and figures about the world sanitation scenarios around the world. This is from the United Nations data. about 1.1 billion people still do the open defecation. So what does it mean by open defecation? Open defecation means they prefer to do the what we call it, the business outside from the outside without the toilet. Okay, it's either they are having the no infrastructure for the toilet, or maybe this is some traditional or culture in the community. So another, hang on, yeah. Okay. Sorry about that, to interrupt you. Okay, so we have another 1.5 billion people with no toilet. Nowadays, when I check the figures for the world population, we have 7.8 billion people in the world. So unfortunately, still we have 1.4 billion people with no toilet, septic tanks, or other means of the improved sanitation facilities. And 2.4 billion people lack access to basic sanitation, okay, which means including toilets and latrines. And 80% of the wastewater, because I want to have this highlight laser pointer here. Okay, 2.4 billion people, okay, more than 80% of wastewater resulting from the human activity discharge direct into the water bodies without any treatment. So this can give effect to the environment, especially. And then every day, quite big number of children die due to the preventable water and also the some diarrheal disease. Okay, so this is examples of the open defecation, okay, in Indonesian's case study. Okay, this has been shared by my colleague from Surabaya, Dr. Eddie, when he came to our university giving a talk, and sharing. So this is the examples of the open defecation where people do their business like these are direct discharge into the main drain. And this can give lots of the effects, okay, through the waterways, health effects, and also the environment. And also it can give a very negative environmental this aspect, health aspect, because the vector, okay, and also the microbial contamination will easily can be spread, okay. So this is the photo of the open defecation. And then they also have this open defecation free, means the community, they have shift their open defecation to toilet like this. So this is a much better versions of the toilet, of the open defecation, as you can see here. So they have cover and everything so that they can do their business more appropriately. Okay, next is about the sustainability and sustainable development. So as we know, to achieve the sustainable development, we must have the three components, which is social equity, economic efficiency, and also the economic environmental responsibility. So for the social equity, we must have the good living condition, equally opportunity for all of the races. We have the social cohesion, international solidarity, and also the maintenance of the human capital. For the economic efficiency, we need to have good and sufficient funding so that every sustainable development and also program or agenda can be achieved. And here, for the environmental responsibility, I think the most important thing is how we can deal and manage our resources. Okay, every country has their lots of resources. So how they manage it, how they utilize it to make it more better and can make sure that the sustainable that the target can be achieved. So what is the materials and waste, the risk, rate of change, and also the natural and cultural landscape that we have. Okay, first of all, for the wastewater, we have two types of the wastewater. So this is generally the definition. So the domestic wastewater comes, as you know, comes from the residential area, commercial, like shopping mall, institutional facilities, and also the recreational. So it contains lots of the decomposable organic matter and also the pathogenic agents. While for the industrial wastewater, it generate a wide variety of the wastewater pollutants, and it's very complex. It depends on the source of the industry that they produce. And this is in Malaysia, it depends on the size of the industry, so that they need to have their own treatment system in the industrial, because this need to comply with the standard of Malaysian for the environment. Yeah. Okay, the contaminants and also the impact. So these are the parameters that we usually check to make sure that the effluent is compliable to the certain standard. Every countries, they have a standard for the effluent discharge after treatment. So if not, so they will give impact, lots of the what we call that negative impacts to the environment especially, and also to the human health. So here, for example, the suspended solid, it can cause sludge deposit and also the anaerobic conditions. And then for the biodegradable organics, they can cause anaerobic condition in the environment. Pathogen can transmit disease. Cholera, we have lots of the new disease today because of the complexity of the discharge, okay, from the various source now, and also the non-point source. Heavy metals are mostly from the industry and also from the mining area also. And we have the refractory organics, which is very toxic to the biota and also the humans. These are also solids, and also nutrients may come from the phosphorus, nitrogen, ammonia that can cause eutrophication in algal bloom. Okay, so here if you can see that the water, for example, in the lake, can appear color like greenish. Yeah, it's actually it's a sign of the algal bloom, which is the nutrients level is very high, but the water quality is not good, so that the aquatic life cannot survive. Okay, next is about the centralized and decentralized system for the wastewater. So what's the difference between the centralized and decentralized system? So in this lecture, I will give you this comparison so that you can distinguish between these two systems. Okay, for the conventional centralized, it's actually conventional treatment. So this has been practiced in most of the countries, especially developing countries. Okay, how it works? It actually the treatment system at one location, and then it can treat so many water at high rates to accommodate all the residential, business, and industrial users. So in Malaysia, in many countries, in developing countries, they use this type of centralized system. But of course, it requires high capital costs and also the operating and maintenance costs. However, it gives lack environmental awareness to the community because they didn't know what happens, because they didn't see the what we call it, the system quite clearly. While for the decentralized system, this is more on the innovative treatment. So they can install their treatment system on site at their house or maybe at their premises. Okay, so it's either point of entry or point of use here. So, but here the volume of the wastewater should be low because it's very specific to treat certain premise or residential area. It's low cost, but the users need to know how to do the maintenance, because this is they need to operate by themselves. But the good thing is it provides a high environmental awareness to the users or to the people that install the system for the decentralized system. Yeah. Okay, this is the schematic diagram of the difference between the centralized and also the decentralized system from the Ashok Sharma, okay, from the journal. So as you can see here, for the centralized wastewater treatment plant, it treats all of the water or effluents comes from this residential, okay, business from the premises here, okay. While for the decentralized, it's on-site, individual, okay. They can have their own wastewater treatment. I will give you an example. What does it mean by decentralized system? Okay, I will give you a few examples. And for example, here also we have the local wastewater treatment plant, very specific for the high-rise building, and certain skills for the some community that they share in the same area, okay, and also the group of units. So this is the meaning of centralized and decentralized wastewater treatment system. So I go for the examples of the centralized wastewater management in Malaysia. So this is our evolution of sewerage system in Malaysia from the 1950 until now, 2000th century. So since 1950, we are using poor flush, okay? So this is a very outdated technology here. After that, in 1960, we converted to the septic tank, okay? And then in 1970, we have more proper system. We use Imhoff tank like this, okay. And then in 1980s, we use like oscillation pond. So it's like a big pond here, doing the natural system of the breakdown of the organic matter by the microorganisms or bacteria. And then 1990s, we upgrade to the activated sludge or biological filter like this. And in 2000, we have most of the system is fully mechanized system. Because of the land space, we need to reduce the land space, and then this is easy to do the maintenance as well. Okay, so this is from the IWK. IWK means Inner Water Consortium. So this company is the in charge of the managing the sewerage treatment plant, the whole Malaysia. Okay, basically where the sewage water goes here, as you can see, the connection. So every commercial, domestic, and also the government premises, they have this house connection, the pipeline sewers, so that it can be pump into the sewer pipelines. And then this the pump will go extract the effluent, the sewage to the STP, okay. And then they will be treated usually by using the activated sludge system, the conventional one. And then it will be having a sludge. This is something that we need to manage. The sludge is either go to the treatment facilities, or after the treatment, it can release to the waterways. Okay. Okay, this is the typical sewage treatment flow process. We have the preliminary and also the primary and also the secondary treatment, which is biological. Yeah. So the core screen, okay, to remove all the large floating materials. Okay, we have the grit removal to remove the gravels, okay, sand and so on, the grease trap. We have the anoxic tank between this aerobic and also the like a equalization tank, and then aeration tank here, and also the clarifier, and also finally the treated effluent here, and finally the sludge. Okay, we need to be, it must be treated before disposed of to the landfill or reused again for the other purpose. Okay, examples of the sewage treatment plant in Malaysia is very large scale. Okay, so the PE, population equivalent, must be more than a few thousands. Yeah, IWK means Inner Water Consortium, sewage treatment plant in Bunos. This is the location, yeah, for sewage and sludge treatment. Okay, we are using standard A and standard B to check and measure whether the effluent is comply with the standard. Okay, so after the treatment, we should check in here to determine whether our effluent discharge comply with the standard A or standard B. It depends on the locations of the water treatment plant. Okay, if for example, you have industrial plant and you have the treatment plant located upstream from the water treatment plant, upstream is here, that means you need to follow standard A. Whilst if you are residential area, you have the STP here, but it is downstream after the water treatment plant, you should follow the standard B. So that means standard A is more stringent than standard B. So this is the unit extracted from the environmental quality for sewage regulation in Malaysia. So this is the standard A and standard B. So for example, for BOD 5, for standard A needs you to have 20 milligram per liter BOD, okay, which is more stringent to apply compared to standard B, which is 50. And you can also check for the other parameters. We have suspended solid, oil and grease, and so on. This is the major contaminants, common water quality check to make sure that the inland waters within the catchment must be applicable to any other inland waters of Malaysian waters. Okay, and then this is for other parameters, for example, the heavy metals. But now the governments are revising to include the micropollutant or emerging organic contaminants, for example, from the pharmaceutical, from the herbicide, pesticide, okay, drugs, medicines, because they are very, very common now in waterways. I think this is become the major global concern too. And then because of the number of the health issues concerning the cancer and so on become increased and become apparent. So the government now revising it to include these organic pollutants in the standard. Okay. And this is examples photo for the primary treatment of the rectangular primary treatment. Okay, this is the primary treatment should be able to reduce the pollution by 35% of BOD and to prepare for the next treatment for the secondary treatment, which is on biological treatment. Okay, examples of the circular primary tank. Okay, this is common in the sewage treatment plant system, but depends on the capacity of the sewage treatment plant. It's either the big size or the smaller size of the PE, population equivalent. Okay, in the sewage treatment plant, we depends mostly on our microorganisms because they will break down the organic materials. Okay, our microbes will break down the organic materials that are available in the wastewater or sewage. Okay, this is the major requirements for the microbial to grow. So they need electron receptor, macronutrients, okay, micronutrients, and also the appropriate environment so that they can having a new cell that having a specific gravity slightly greater than water that it can be removed, okay, easily by the gravity settling. So this is what we aim for. And then the new protoplasma, which is organic, to be measured as a BOD in the effluent. So we measure target this BOD should be lower after the treatment. Okay, we have a loss of the abundant microbes in the wastewater aerobic treatment. Okay, this is a wastewater, a mobile rectifier, ciliate, and so on. Okay, I guess I'll give you some examples. Okay, this is the aeration tanks in aerobic treatment. We also have anaerobic digester for some sewage treatment plant, but this is to cater the very high strength of the wastewater. So with the benefit from this biogas anaerobic digester, they produce the biogas. Okay, methane, so that it can be used for energy. Yeah. Okay. And this is examples of the microorganisms growth in the activated sludge. Okay, the operation here. Okay, they must have the aeration tank. This is the conventional method, and also the clarifier or settler that can settle all of this sludge in here, so that it can treat the wastewater. Okay. In Malaysia, we still have a few stabilization pond, but not much, because now they convert everything to mechanical system. Okay, so but the mechanisms of the wastewater treatment in the stabilization pond is like this. Yeah. So we have the sunlight. This is a very natural process. They have the photosynthesis, and then how the organic and then the bacteria biodegrade the organic matter. Okay, for the CO2 treatment plant, they can use some latest technology to enhance the breakdown of the organic matter by the bacteria. So like this, for example, they use certain media, the high density polyethylene, for example, HDPE, and also the polypropylene to cater this, to make sure that they can work faster. Okay, and also, for example, of the trickling filter, where the slime grows, where the bacteria or microbiome attach in here, so that it can biodegrade the organic matter. So this is the byproduct of the wastewater treatment plant. Okay, as you can see, there are lots. So this need to be managed carefully. Okay, before it can be reused again for other purpose. For example, for landscaping. It need to be make sure that the sludge inert. That means there's no contaminants, no other major heavy metals or other constituents that can give effect to the human health and also the environment. Okay, what are the sources of the sludge? So we have two. Okay, it's either primary or secondary. Sludge from the bottom of the primary clarifier contains about 3 to 8% solids, and mostly 70% are organics. Okay, while for the secondary sludge, it contains lots of the microorganisms because of this biological reaction, yeah, biological process, and also inert materials that can be wasted from the secondary treatment sludge. So you must know from where your sludge coming from, so that you can treat it properly, and then it's either you make decision when either you want to reuse it again for the landscape, for the some fertilizer, or so on. It should be come from these two types of the sludge. Okay, this is the table of the sludge characteristics. So as you can see, it has lots of volatile solids, okay, protein, nitrogen, phosphorus. That means it offers good opportunities for the nutrients. Okay, but must be eliminate the toxic materials in the sludge before it can be reused again. Okay, these are the basic process for the sludge treatments as follow. We can make it thicken, stabilize it, make it a condition with certain chemicals. We also dry it, dewatering, reduce it, and then finally we dispose into the sanitary landfill, or we can use it as a salt incorporation. Okay, for example, a golf course incorporation for the larger scale. Yeah. Okay, for the sludge disposal, we can do this land spreading for lawns, garden, agricultural land, forest land, golf course, and also municipal solid waste landfill for the subtitle D. And we can utilize it for the other material, like for example, for the construction waste, construction materials. Yeah. Okay, this is the common practice of the sludge treatment process in Malaysia. Usually here we have the sludge, we transfer it to the thickening process. Okay, this is the gravity thickener. We use the gravity to thicken the primary sludge, and we are using the mechanical thickener using the polymer to thicken the secondary sludge. Yeah. And after that, the digesting process, we stabilize it, and then the gas produced from this process is collected and flare. And then drying process, okay. Usually in here, a polymer is added to further dry the sludge cake. And then the treated sludge is simply sludge into the storage before disposal. And finally, it is sent to the landfill. It's either can be used as a soil top cover, land reclamation, or land application for agricultural land, and also forest land. Okay. Okay, the second one is about the decentralized wastewater management. Okay, also case study in Malaysia. Beside the sewage treatment plant, for the individual house, for example, in the village area or individual where they have disconnected from the sewage treatment plant, they use septic tank. Okay. Okay, septic tank, the concept is they use anaerobic treatment for the raw sewage. It's like this. So this is the chamber, inspection chamber, and also the sludge in individual septic tank. But this one actually, the owner of the house need to have awareness on how they can dislodge regularly to keep the environment clean. Yeah, because this is always be overlooked by the house owners. Okay, this is the process of the anaerobic for the septic tank. I believe that this is common for septic tank around the world. They use the septic tank for their sewage treatment. Household water is usually retained for 1 to 3 days, and then they form the scum here, okay, to help the anaerobic condition, and then it can be dislodged. This one accumulates. But we need to do the dislodging, okay, for every 1 to 5 years. In Malaysia, usually around every 2 years, they always remind the house owner to contact the company to do the dislodging. Yeah. But this one something that people always ignore and just keep it, what we call that, maintain as it is. So the problem is it can give a problem to the environment from the leakage. Okay, as you can see that here, the efficiency of the septic tank, it depends on how regularly you dislodge your sludge. Yeah, if you are which has not been dislodged regularly, so the mechanism it will be like this. Effluent with raw wastewater is they have a very thick and very high number of the sludge. Yeah. Okay, for this one, this is a very good system where it has been dislodged regularly, and this the photo of the septic tank that after the dislodging. Yeah. Examples of the septic tank for the anaerobic digestion system for the sewage treatment plant. And then we have the guideline, guiding principle to design the septic tank. Okay, we follow the WHO 1992 because in here the principle is we need to provide the sufficient retention time for sewage in the tank to allow separation. We also need to provide stable hydraulic condition for the efficient settlement and flotation, and to make sure that the capacity is large enough, the tank, to store the accumulated sludge and scum, and there's no blockage. Okay, and everything must be in order. So this is the basic principle if you are to design the septic tank. Okay, because to make sure that our sanitation is sustainable, one of the most method that we can go for is renewable energy by using anaerobic digestion. So this is becoming an increasingly popular now because from the anaerobic digestion, we can convert it and we can get very good valuable of biogas, okay, from the methane. So it can be used for energy, electricity, for generating the your turbine or whatsoever. Okay, so digestate is the solid and liquid digested material produced in anaerobic digestion. and it has a lots of the valuable and nutritional values, nitrogen, phosphorus, and potassium. So it can be used as a fertilizer for compost and also the animal bedding. Okay. So these are the process of the anaerobic digestion. So if you have lots of animal manure, okay, energy crops, even for the food waste, you can create your anaerobic digester in here without oxygen. It must be airtight, sealed here, so that after a while it can produce the biogas. Okay, and it can go to the CHP unit and can be transferred to the electricity grid. So the biomethane here also now, people go for the how it can convert it into the fuel here, all right? And even for the digested, we can store in the lagoon and it can be used for the biofertilizer. So everything can be consumed sustainably. But the problem is with the anaerobic digester is sometimes somehow it's very slow process. In order for you to get the biogas, it takes a while. And the good quality of this biogas production is from the animal manure. I think the rest is the process is very slow. Okay, I'm sharing with you examples of the project on the anaerobic digester here in the sewage treatment plant in Jelutong in Malaysia. Okay, they have this biogas AD, anaerobic digester. So it produces biogas, can generate electricity for the internal consumption at Jelutong sewage treatment plant in Pulau Pinang, Penang Island. Yeah, this is at the north of Malaysia. So currently this is the plants produce an average of the 800 meter cube of biogas each day, and how much it can be produced. Here, 170 kilowatt gas engine has been installed, and from there it can release the electricity. Okay, from the released biogas, and also it has order control system, a lift in the digester equipment building in here. Okay, so this is example in Penang. Okay, so this is another example of the anaerobic digester by using the POM. POM means palm oil mill effluent. Yeah, because in Malaysia we have lots palm oil plantation. We are the second largest after Indonesia and also Thailand. So we have lots of the POM. So the POM, instead of just release into the treatment system, we can also generate the biogas by using the anaerobic digester like this. So it can produce the biogas. Yeah. This is example of the anaerobic digester in Pahang, yeah, in the palm oil plantation. So this is the list of some of the oil palm mill that they have the biogas capture facilities. So the list is progressively continuous. Now the registered is about 18 plantation of the palm oil that they have this national biogas implementation. And this is our target, our national target, national key economic areas, national biogas implementation. So the government also is very supportive to make sure that all the palm oil plantation install the biogas. Okay, why the palm oil mill actively involved in the biogas production? So what's the benefit? Because we want to commit with the Clean Development Mechanism, CDM, under the Kyoto Protocol. As you know, that Kyoto Protocol is the protocol that need to cover the greenhouse gas emission or carbon emission. And also it liaises with the United Nations Framework Convention on Climate Change to help the developing countries achieve the sustainable development through the sale of certificate of emission reduction or carbon credits. Okay, so this is a very our approach on how we can commit to the clean CDM. Okay, so in Malaysia, we facilitate by the Conservation and Environmental Management under the Ministry of the Natural Resources and Environment. So the project is actually the CDM project activities bring the following the benefit. So as I mentioned before, we want to reduce the carbon emission under the Kyoto Protocol. We help the palm oil industry meet their stringent sustainability requirement. Okay, we also need to hand-to-hand reduce the emissions of CO2 and emit it into the cash flow. That means it can give a win-win situation benefit to the industry and also to the environment, and also it can give a positive image to the industry and also globally. Yeah. The CDM approval mechanisms are able to create the new community in the form of the CR certificates. Okay, besides that, we also have several food waste projects that convert to the biogas for electricity in several food courts in Malaysia here. Okay, this is since 2017. Okay, I hope that I have given you enough explanation on the anaerobic digestion. And now I would like to explain on the greywater aspect. Okay, because for the wastewater, we have one is black water, another one is greywater. Greywater means anything except toilet waste. So the water from the kitchen, bathroom and laundry considered as greywater. But certain country like Australia, they don't they don't include the kitchen waste greywater as the greywater because of the high pollutant level from the oil and also from the fat, okay, and grease. So a big number comes from the greywater. It can consist of 50 to 80% of the residential wastewater. So the problem is here, for example, in Malaysia, we have lots of these direct discharge of the greywater into our river. For example, in Kuching, yeah, you can see. For example, if you have a restaurant premise, only the toilet goes to the sewage treatment plant, but the rest go direct into the river. So this is give a very detrimental effect to the environment for the long run. Okay. So this is one pilot project, Huising Garden in Kuching, by the Professor P.D. Jensen. He's a Norwegian, very closely work with the sanitation water. And this is one of his project of the wetland system, where the wetland system. Wetland means we use lots of these biofilter plants, okay, and also plantation to purify the greywater. So this is the system that they install in the underneath, okay, from the septic tank, okay, the water, because due to some excess leakage and so on, the water coming through to here, pumping, and then they have this pre-treatment biofilter, and then they have this horizontal subsurface flow wetland filter. So naturally, the greywater will go through and then filter, purify themselves from this flowing water with the media of the subsurface flow. And then this is the level control and sampling part to check the condition or quality of the water. Okay, as you can see here, this is the photos of the different levels of the treatment, and then you can see the clarity of the water from the first chamber, pump sump, and final discharge. So this is very clear. That means the wetland system is very efficient to treat the greywater. Okay, this is the minister during the officially during the event. Okay. Okay, from this treatment, the result showing that the BOD can go lower of 2 milligram per liter, which is very good. The total nitrogen can achieve 2.2 milligram per liter, total phosphorus, and this is for the fecal coliform. So this is a the achievement is very good from this biofilter using wetland system to treat the greywater. Okay, besides that, this is my so-called some current project dealing with greywater. Okay, because I have done quite numerous project on the greywater. Okay, so we have 4 basically run by my postgrad students, and also some of it are still under running and then supported by the government under the research grant. Number 1 is about how the greywater affect to the water body. Okay, this one we are using the modeling, filter and pelts, and then we can also use treat the greywater by using the local waste materials. And this one is more on the photocatalytic, because in Malaysia we are having the sunlight throughout the year. No season, no 4 season. So that means we have sufficient enough of the sunlight to do the photocatalyst process. Okay. Okay, this is the common photo on practice of the how greywater discharge from the household. This is just near to our university. Okay, as an example, our individual house, okay, in the quite suburban area. So they have the greywater discharge might be comes from the sinks, bathroom or laundry here, go to the main water body. So the condition here, we have lots of some algae here, the green one. So the problem here, this is another case study, the greywater from the bathroom, from the discharge of piping, go to this drainage where along together, because we have the lots of the oil palm plantation from the fertilizer, from the runoff entering our water bodies. It can cause bad odors, okay, and also eutrophication here due to the excess nutrients in the wastewater. So because of that, this is our main concern, and then we want to check whether the greywater is actually the one, the culprit that give effect to the water body, especially to the river. Because in Malaysia, in many countries around the world, river is our main water supply. So that means we need to conserve it. Okay, this is the step. We need to measure the hydraulic parameters. We also need to have the sampling for the BOD, DO, pH, stability, and temperature. For the now, because of this project, we include 7 stations, and then we calculate by using this very basic model, Streeter and Phelps model, yeah, to know actually for how far our greywater can go and give effect to the river. Okay, this is the overview for the sampling locations of the greywater discharge and also the stream flow. Okay, in this case study, we calculated how much houses in every drain A, B, C, D, and E. Okay, and then we calculate the distance. Okay, the stream distance. Okay, this is the houses and this is the main river. So every greywater flow discharge in here for every channel of the ditch, and then if we go to here to the river, main water supply, river here, river flow. Okay, at the real overview, so this is how we calculated upstream, downstream, the distance, okay, for every channel here, and this is our river flow. And then this is what happens in the Streeter and Phelps model, how we see the degradation and decomposition of the greywater. Here, S1, S2, heavy pollution. Yes, because it's very near to the source of pollution discharge. But at this, after certain distance, we can see that the water become cleaner. Okay, but this is not our reason to not ignore the existence of the greywater, because there will be possibility of the non-point sources of the other source of pollution. Okay, can come through. Okay, this project also is one of the project of the Greywater. We use the local waste material. This is to reduce the pollution load into the river. So this is like we trap by using our filtration, so that the water that goes into this river is much safer. In here, we use local waste material, clamshell, ceramic and sand, like this as a filtration. But this needs to do some maintenance work, cleaning. So this is a quite tedious work. So not many people like it, but it able to reduce the COD removal up to 85% by using this kind of filtration. Okay, but this is only the pilot scale. Okay, work for this project has been published in the journal, as you can see in 2018. Me and also my colleague have been published this work for this journal, for this work. Okay, for the Greywater future opportunities, we have lots of these treatment strategies to offer in terms of physical, chemical, and biological. But it all depends on how many the funding, okay, the aspect of your Greywater, the strength, and then what you aim for. Are you going to reuse it, recycling it, or you just want to for the safe disposal? So you need to make a good decision. But my main concern is, for example, we take a bath every day. Yeah? I believe everybody does too. Shower. In humid country like Malaysia, we take a bath every day without fail. Because if not, we are feeling very sweaty, and it's not easy. It's not pleasant. Okay. So, but the problem is from these bathroom activities, we also create the personal care products. Okay, so with this we call it as a light Greywater that contains the xenobiotic organic compound. XOC means xenobiotic organic compounds. Yeah, and how we can reduce it? This one. Okay, because our concern is the house that direct discharge into the waterways like this. For the urban area, that all the Greywater channel into the sewage treatment plant is okay. But for the individual house, suburban, village house, they don't have this. The system. So they just discharge off into the drain. So these are the issue. The Greywater and also the personal care product produce the xenobiotic organic compounds. So this is mainly our now becoming increasing popular and also become our main concern. Okay, because the micropollutant is something that we cannot see, we cannot always ignore about their appearance, but suddenly it can become very important for us to do something about it. Okay, for example, in here we can do photocatalytic degradations of the xenobiotic organic compound by using some modifications of the semiconductor. We can also design the compound parabolic concentration. So the water can be reused for the non-potable uses, like for the cleaning, okay, and also for the toilet flushing maybe, and it can offer very good water saving. Okay, this is examples of the design. You can construct the CPC reactor in here. So we have the flow meter, we have the Greywater source, because we have a sufficient amount of the sunlight, so we can do this recycling or reuse potential of our Greywater. Okay, one other thing is to do the degradation of the organic compound of the Greywater, we also can use zinc oxide PVP nanoparticles. So now many researchers are going for the nanotechnology, Okay, so here we absorb the photons by a semiconductor. We have the sunlight, and then because of the photocatalysts have the benefit of the energy saving, high efficiency, there's no secondary pollution, and it can be operated at mild condition, and it can be powered by the sunlight. So here it is. So the metal can be converted into this CO2 and plus H2O, which is harmless. The photocatalyst process. Yeah. Okay, so in my laboratory, we use some green synthesis of the nanoparticle. For example, here, using the coriander sativum leaves. Okay, in my local interpretation is ketumbar. Okay, and this coriander been used many in our food dishes. I think in most Indian, okay, they eat Thais, okay, Thai food, they use lots of the coriander sativum. So this can be actually extracted, and we can get the zinc oxide here extraction to do the degradation. Yeah. So this is some of the process. Actually, the process is not you need to boil, but you need to having also several process to form the zinc oxide. Okay. So we have this is the lab base. We have the nanocatalyst trixiloxane solution is our grey water, and we can see how this reaction can be degraded with the help of the sunlight. Okay, here. So this is the photocatalytic degradation of the trixiloxane by using the powder nanocatalyst, and we can measure the efficiency of the degradation of the grey water by using this equation, the remover. And actually, most of my work on the Greywater have been published in this research book, Management of the Greywater in Developing Countries in 2019. Yeah. So everybody, if you are interested to have this book, you can contact me. Okay, because I have a bit experience during my PhD in Perth, doing Greywater study. So this is some of the sharing on how they use the decentralized wastewater treatment. Okay, it's a case study. Okay, the problem of this Western Australia in Perth, Perth is the capital city of the Western Australia, is the lack of rainfall. Okay, they don't have much rainfall, and then the population is increasing, but the sandy type soil makes what we call it, the soil is not really fertile, and there's a potential of the nutrient leaching, okay, from the land. So because they like to do, they have a very usually for the normal common house, they have a very big house and big lawn, so they need lots of water. Okay, but the garden consume approximately 54% of water, and then this is a very big number. Looking into the just a little rainfall that they receive, so everything must be the water must be efficiently managed. Okay. Okay, so examples of the Greywater recycling system in Perth is here. They have a very established system. Even you can have it, they sell it in the shop. Yeah, you can have it to easily to install in the warehouse. Yeah, that means easily can be get. Here, how the grey water diverted to the grey flow system, how they recycle the grey water. For example, in one house, they have this typically weekly water usage in 4 occupants, about this much, 150 liters, 100 liters, and for the bath, 1750 liters. So approximately 2,000 liters per week of greywater. So if they install this greywater system from this company, for example, there are lots of company offering a very good system. They have this filtration and aeration. The purple lines mean if you irrigate your greywater by using greywater, you must able to distinguish. Okay, in Perth, when I see this sub pipe drip lines in purple, then okay, they use greywater treatment. Okay, with reuse, recycling. This can save up to 60% of the potable water from the scheme water. It can reduce the water bills and also can beat the water restrictions, especially during the dry season in summer. Yeah. Okay, examples of this photo when they use water reclamation, okay, in order to conserve the water. Okay, this is the garden. Usually they will have this subsurface drip line, greywater treatment here to irrigate the water and also to irrigate the lawn, okay, the flowers in their gardens beds. Okay, as a conclusion, now we go to the conclusion. Sustainable sanitation is actually an approach that has to be economically viable, socially acceptable, technically and institutional appropriate, and you must use the wise utilization of natural resources you can use. So this is very necessary to protect human and also the environmental health. So recycling, reuse, energy recovery should be integral to all scale. Okay, like my example, we use the anaerobic digester from the palm oil, which is a very brilliant method to produce energy biogas so that we can conserve it. In underdeveloped area where there are significant deficiency in financial resources and technical support, so you can use some decentralized wastewater treatment, okay, on site. But this must having some educational awareness because house owner, premise business need to know how to do the maintenance, okay, if they have on-site treatment system, okay. With that, I end my presentation. Okay, this is the research center of the Micropolitan Research Center in our faculty. You are welcome to join us. Our Facebook is in here, and then we also can you can communicate with me if you have any interest to do in any water environment, even for water resource research or collaboration in future. So terima kasih. Thank you so much for listening.
Thank you so much, Dr. Maya, for the informative presentation. And I think we invite Associate Professor Dr. Aslina to start her presentation so that we can save some time. We might open the discussion at the end of the session later on. So the floor is yours, Dr. Aslina.
Okay. Thank you. Okay, so can you hear me well, Dr. Wisam?
Yes, yes, it's clear.
Can you see the slide now?
Yes, yes.
Okay. Okay, Assalamualaikum and a very good evening, everyone. I'm Dr. Aslina Abdul Kadir from the Faculty of Civil and Built Environment, UTHM. The title of my presentation today is Sustainable Solid Waste Management. So I came from Malaysia. My exact location is in Batu Pahat, Johor Bahru, which is near to Singapore. And I'm attached with one of the Malaysian Technical University in Malaysia, which is University Tun Hussein Onn, Malaysia, just like Dr. Maya just now, and also Dr. Wesam. We are from the Faculty of Civil Engineering and Built Environment. So all the audience are please welcome to our university, and we are more than welcome to have any research collaboration. So the title of my presentation today is on the sustainable solid waste management. So I'm going to have like 5 pillars, which is the introduction, challenges, concept of sustainability, waste management, as well as conclusion. So as for the introduction, can you please look at this figure and think for a while, why is this happening? Why in this era of 2020, the waste are still not properly managed and also disposed? So this is still happening in Malaysia and also other countries as well. So I think in this era of 2020, we are expecting that our vehicles are flying on the streets and so rapid urbanization and so on. But this is still happening, which is from maybe 70s up till now. So we have to do something about it. So as we all know, I think you guys already know that environmental pollution always refer to improper disposal method. So whatever means that we do, if we do not dispose our waste properly, is going to affect the environment. Whether it will be a water pollution, air pollution, or maybe human impacts and so on. So can we think for a while, where does our solid waste go? Have you ever sit and think for a while, where does your solid waste go in a day that you generate daily in your life? And how much did you actually produce in a day? Because we keep on producing waste, but we do not know where actually does our solid waste go. So because if you see this figure, the illustration of the boundaries of the integrated waste management system, we as the producer always stop at the when we put the waste outside of our house. Then it depends to the waste collector to collect our waste, for them to transfer it safely to the landfill, or maybe they are going to recover it for materials recovery, recycling, or composting, or they are going to convert it into energy. So as if we are, as the producer or the generator, do not care about the waste that we produce, which is wrong, okay? So I just want to recap on the definition of the solid waste so that we are on the same page. The solid waste are the waste arising from human activities and are normally solid as opposed to liquid or gases, and discarded as useless or unwanted. Normally, you are focusing on the urban waste opposed to agricultural, mining, and also industrial waste. Normally, we just use the term solid waste, but actually solid waste have different categories and also classification. For example, solid waste, we have municipal and also other waste, for example, construction, industrial waste, auto bodies, and so on. Under the municipal solid waste, we have different classification, which are garbage, or normally they say organic waste or food waste, which is degradable, and also rubbish, which is non-producible waste, and then they are normally that we use for recycle. For example, plastic, glass, paper, cardboards, and also metal. And under rubbish, which is non-producible waste, there are 2 categories, which is trash and also non-combustible. Normally trash is all the bulky waste that we keep in our house. For example, old coach, mattress, television, refrigerator, and so on. Okay, so that we already know all the definition of solid waste. So now we are on the same page, we can move on to the next one. So what are the challenges that we are facing right now? Why we still do not dispose our waste properly? So there's a lot of causes and also impacts of inefficient urban waste management. So there are like 6 factors, because the causes and the impact of the inefficient urban waste management in cities or towns are always interrelated, just like this figure. Usually local government try to cater or maybe implement short-term end-of-pipe solution that involve partial collection. For example, they just collect 50 to 60% of the total urban waste, and then they neglect the others. So this approach is not solving the problems, because we only like located the waste, often outside the cities into rural areas, and it's going to increase the soil and water pollution, aggravates the greenhouse gases, and also increase the difficulty of the final treatment of the whole waste. So it is actually not good to practice this kind of practices, but we must admit that we have low local capacity and also resources. Another thing that we also have lack of awareness. We as generator of the waste is lacking of awareness about the efficient waste recovery processes and also the minimization practices. Sometimes this is also accompanied by very bad or very ineffective policies in municipal solid waste. But sometimes we are not tasked as the producer or the generator with the responsibility to do waste separation at home. At least we have to separate our waste at home. And also sometimes the taxes for urban services such as waste collection and disposal are very low. So it will make the local government constantly in need of capacity building and financial resources to improve municipal solid waste management. So one of the things that I would like to highlight is that on the no segregation of waste at source, which is our responsibility, and also low local awareness of 3R practices, that is reduce, reuse, recycle. That is also our responsibility. That is the least thing that we should do as a generator of the waste. Okay. So as for the solid waste generation, I think this is normal. As the population increase, normally the solid waste generation will also increase. But the number is quite huge according to the increasing of the population. When we look at this pie chart showing the global waste composition in percent, so we can see that the highest composition of the waste is food and green, which is degradable material. So in this case, I think we can really reduce the amount of organic and also food waste if we properly plan what we eat and what we don't eat. So 44% is going to end up in the landfill. If we could avoid this 44%, we are going to increase the lifespan of the landfill. So please eat properly and also do not waste your food waste. Okay, that is the number one. And then number two is paper and cardboard, which is 17%. This amount also we can avoid from the landfill because we can recycle the paper and also cardboard. The third one is the other waste, and the fourth one is the plastic. I want to talk about this plastic waste because the plastic waste can be in the environment like forever. It cannot be degradable because it is the characteristics of the plastics. And then once we use the plastic and we throw it away, it's going to be in the environment like maybe 1,000 years. So it's going to have like impact forever to us. So what is the best way along the pipeline? We have to cater this issue, especially on the plastic waste. And then we also, during this COVID-19, so many plastic waste are being generated significantly due to the maybe takeaway home or takeaway food, and also all the PPE are made from plastics. So the plastics waste amount are increased quite significantly during this COVID-19. So it's going to add up to the problem, which is now already at risk. So we have to do something about plastic waste. We can learn later from the successful countries or case studies. Okay, when we focus about the global waste management, the composition of the waste being produced are quite similar. The highest portion is from the food and green, and then followed by paper and cardboard, plastic, glass, and metal. But the highest amount of regional waste generation annually is from East Asia and the Pacific, which is 468 million tons. Is quite a lot. And then this number is going to increase by 70% in 2050. So I think we really have to sit and think so that we try to reduce the waste that we produce in our daily life. Okay, if you see from the chart there or the graph, it says that the low income countries, over 90% of waste is mismanaged. So this is going to increase the emissions and disaster risk, which affects the poor disproportionately. When we are focusing on the waste management in Asia region, we can see that the municipal solid waste is very high at upper middle income. This is due to the urban rapid urbanization, the materials manufacturing that they are needed in the upper middle income level that makes it the highest in terms of the municipal solid waste per capita. So in case of the regional trends in pollution and waste, it is going to be increased up to 3 million tons by 2025, which is double the amount. Obviously, the cost to manage it also will increase by 2025. And unfortunately, approximately 10% of the solid waste is going to end up in properly engineered management landfill. And this is the highlighted, 90% is going to be dumped in open dump site. We already know that open dump site normally don't have liners and is going to affect the environment. Because in developing countries, normally the population will continue to grow and the waste per capita is going to follow the trend. But for developed countries, normally the per capita rates is double and is quite stable. Okay, this slide shows the solid waste management cost, but it is in Ringgit Malaysia. For example, in Fukuoka, Japan, they spend 1.3 Ringgit Malaysia per kg of waste. New York spend 0.82 kg per Ringgit Malaysia kg per waste, and London 0.41, and so on and so forth. So we can see that if you want an effective and also efficient waste management system, we have to spend a lot of money. Okay, in terms of global treatment and disposal of waste, we know that we have many disposal methods and options. We have sanitary landfill, we have incinerator, we have composting, recycling, open dump, so on and so forth. But the highest percentage here is the open dump. Okay, open dump followed by 13.5%, which is recycling, 25.2%, which is landfill unspecified. Open dump and landfill unspecified, I would call it as similar, okay? And then 13.5 is by recycling, and 11.1 is by incineration, and 7.7 is by sanitary landfill. In Malaysia, we only have like 8 to 10% of sanitary landfill. So the number is quite low compared to the amount of waste that we produce. We have like 299 of unspecified landfill or landfill at other level, but for sanitary landfill, we only have 8 to 10. Okay, when we talk about landfill, because you see that 33% is on the dump site as well as the unspecified landfill, or we call it as dump site as well. What is the most disadvantageous point of this dump site or this landfill, unspecified landfill, is that normally we have so many different level of landfills. We have level 1, level 2, level 3, and level 4. So level 1 is normally they have perimeter fence and drains. Then they can upgrade to level 2 with gas removal system. Level 3 is leachate recirculation system. Level 4 upgrade with leachate treatment system. If we are talking about sanitary landfill, they are going to have all the available equipments and facilities. But if we are talking about dump site, they do not have all the facilities. If we are talking about unspecified landfill, maybe they are going to have perimeter fence and drains, just to mark that that is the location for unspecified landfill. But normally they do not have liners. That is the most disadvantageous of the unspecified landfill as well as dump site. So this slide shows the figure of dump site. You can see that from this dump site, they do not have liners, and we just excavated that area and then put the waste, and then it is not being covered properly. There's a rain, and then the rain will percolate through the waste, is going to produce leachate, And then this leachate that contain high toxicity is going to percolate through the waste and also the soil, and eventually it's going to the groundwater as well as the surface water. So it's going to cause water pollution. Okay. Okay, on the right figure, it shows the normal dump site that we can see normally in Malaysia and also other countries. If we are talking about the sanitary landfill, which I said only have maybe 8 to 10 of the sanitary landfill in Malaysia, they have like maybe 13 fully equipped facilities. They have the capping layer, leachate drainage system, daily compacted waste field, they have leachate pumps, leachate collection, leachate treatment plant, so on and so forth. So it is so fully equipped with all the facilities needed of a sanitary that could dispose the waste properly and also minimize the contamination to the environment. So this is what happens if we dump our waste in a dump site or the unspecified landfill, which hold quite a bigger percentage in the pie chart just now, all over the world. So this highly mixed waste, we have organic waste, recyclable items, other types of waste, we mix it together in a plastic bag. We as a generator just put it outside of our house and we expect, okay, the collector will collect the waste and my problem is done, okay? So this is what happened at the dump site. Various types of waste, various types of dump site or unspecified landfill. And unfortunately, we also dump medical waste, aerosol, toxic waste, as well as electronic waste in the normal dump site or unspecified landfill. So it's a big no for the hazardous waste in the landfill because it contains very high toxicity, which is not suitable. It should be in the secure landfill, not in a dump site, not on the unspecified landfill, not on the sanitary landfill. It should be in the secure landfill or incinerator. Even though solid waste and hazardous waste seems like brothers and sisters, they are waste, so hazardous waste may be the brother of solid waste, but no, they are not. So hazardous waste are very dangerous if it is handled wrongly. Because of the characteristics, they have these characteristics, 4 characteristics, which is ignitability, corrosivity, reactivity, and also toxicity. So it is not supposed to be in the dump site, unspecified landfill, or sanitary landfill. It must be in the incinerator, either treatment, or also secure landfill. So when we dump 33% plus like 17% on the unspecified as well as the dump site, we are going to increase the impact on the water pollution. We know that all the waste that we generate and also we dump at the dump site or the unspecified landfill or non-sanitary landfill, every ton of the municipal solid waste is going to generate 150 liters of leachate, which is 2.5 million liters every day. So the leachate will flow and also percolate through your waste every time there is a rainfall and also run off, and it's going to create contamination to the water or the surface water. So if we see that 150 liters of leachate, which is 2.5 million liters every day, I think every single one of us here could have one private swimming pool of leachate. So we have to think carefully before we throw our waste. So this figure or slide shows that the discharge of the landfill leachate into the river, and then the leachate will be accumulated, the leachate will flow towards lower ground, and leachate will be mixed with the surface water, and the leachate is going to create their own pathway. So the effect is going to be towards the water quality as well as the ecosystem and human being. In terms of air pollution, if we do not dispose the waste properly, sometimes you also prone to open burning. But when we put our waste, especially food waste, because food waste is biodegradable, is going to create gases, especially methane. But methane is an explosive gas. If we do not release it to the environment, it's going to blow up. So we have to be very careful at the landfill site or the dump site. So sometimes they are going to release it using passive release, but it's going to contribute to the global warming. and also corrosion of the metals nearby. So these are some of the figures shown that the gases produced from the leachate, gases bubbling out from leachate and cause bad smell. Sometimes we just do a simple passive release of landfill gases into the atmosphere because we do not want them to explode inside. And we can see the corrosion of the metal-based materials, corrosion of the concrete, and open burning obviously is going to cause very huge air pollution. As for the soil pollution, because we practice the open dump and then we just leave our waste there, is going to percolate through the waste and also contaminate the soil. Mostly the soil fertility is going to be a mixture of toxic substances and also decaying organic material. So sometimes the soil itself is non-fertility, and also is not suitable for any activities of plantings and so on. So it's also going to risk human contact. Expensive remediation technology will be needed if the soil is really contaminated, and obviously a place where we use for disposing waste, normally the land price will be very low or devalued. So leachate migrates through refuse and contaminates the soil. This figure shows that the soil pollution due to soil losses its volume in terms of its chemical, nutritional, and also requirements. We mess up the ecosystem of the soil, and infertile trees due to contaminated soil. So we could not do any plantation activities. As for the noise pollution, it is very minimal, but it is there. Sometimes the on-site operation noise sources fixed noise from ammonia treatment plant and leachate treatment plant, but this is only for sanitary landfill. And sometimes the on-site traffic noise due to refuse vehicle movements, such as drum trucks, traffic, bulldozer, waste spilling and barge noise, and also the birds chirping is one of the major nuisance in landfill. So the figures show some of the noise pollution, not very significant, quite minimal, but it is there. The dump truck transfer waste from transfer station to landfill site, the loud banging noise in landfill, and also noise from birds and other wild animals scavenging for food. Another impact that we could not neglect is the health impact. Because we just select a place, open dumping place, we excavate the soil, we put the soil there, but we do not cover it properly with other soil, and we do not compact the waste properly. So the waste is exposed to the environment. What happened is that it is going to become the breeding ground for various pests, including rats, flies, and also others. And it's also going to invite the scavengers of animals and also human. So because our waste is not covered properly with soil, and then we do not compact it properly, the flies is going to cover every inch of the surface, especially on the food waste. That's why I said earlier, please reduce the amount of food waste to the landfill. And then the scavenging by the animals, they are finding food at the dump site area, and also the illegal immigrants scavenging for recycled materials because it is value for money. But what happened is that they are going to tear up all the plastic bags, and they are going to expose more of the waste to the environment, to the rainfall, and it's going to produce more environmental pollution, which is not good. Okay, one of the disposal method is the incineration. Incineration has its own advantages as well as disadvantages. One of the advantages of the incineration is going to reduce the volume by 85 to 95%. And it is such a huge amount that we could decrease by using incineration method. And then we also can recover conversion products as well as energy. But major concerns is on the air pollution as well as the sitting, because the residents have this mindset, not in my backyard. We can implement incinerator, but not near our house, okay? Because of the air pollution. So some of the issues on the incineration is that all the ashes that is being produced from the high temperature burning have to be disposed and also treated properly. It's either they treat it first and then dispose it later in the secure landfill. And then there are also many concerns by the health effects of dioxin and furan emissions, which is carcinogenic from the atmosphere from all incineration. So all incinerator normally do not have a good filter, so they are going to produce dioxin and also furan emission, which is carcinogenic to the workers and to the surrounding. Other than that, sometimes the incinerator will produce high concentration of heavy metals at different level, because they are going to burn everything, but they are going to accumulate certain heavy metals in the ash. So it is quite dangerous as well. That's why we have to properly dispose the ash. And then in terms of building and operating, incinerator normally requires very long contract periods to recover initial investment costs, causing a long-term lock-in. It is quite expensive and it's very long term to get the investment back. And the incinerators also produce fine particles in the furnace during the firing session. So even with the modern particle filtering of the flue gases, a fraction of these are emitted to the atmosphere. So it is quite dangerous to the workers as well. And also the local communities' perception, which are not in my backyard. They are opposing to the idea of locating incinerators near to their residential area, which is for me, I also will stand up for not in my backyard mindset. Okay, other than that, some of them are thinking that this incineration, because we can sell like maybe 1000 kg, we are going to end up like maybe 0.02 kg of waste. We can just eliminate this 2000 kg of waste. So it's going to prevent or minimize reuse and recycle, because sometimes the generator or we as the producer of the waste will think that why should we bother to recycle? Because incineration can just discard the waste or burn the waste up to 80 to 90%. So it's going to minimize the recycle activities. And sometimes supporters of zero waste consider that this incinerator method is a barrier for recycling and separation. And some of the generator and producer like us, we can think that why should we bother to separate the waste from house? If we just use the incinerator, all the waste is going to be gone just like that. So why should we bother to recycle, to separate and so on? So this is not good, because in our hierarchy of integrated solid waste management, we should reduce, reuse, recycle and everything before we dispose the waste, okay? To protect the environment. And last but not least, the incinerators, according to UNIMIA report, it says that it is contribute to the climate change because of the gases that they produce. So we can't deny that. But they have a lot of advantages. It is very excellent technology for all substances with a heat release potential. The bulkier the materials to be incinerated, the greater the reduction in the volume of waste. As I told you earlier, we send like maybe 2000 kg of waste, we are going to bring back 0.02 ash maybe. So it's a good way to reduce the number or the volume of the waste. It's also going to detoxify the combustible carcinogen, mutagens and also tetrogens. It means it's going to stabilize all the toxicity in the waste by the burning session, and it's going to reduce a lot of leachate that normally comes out from the landfill. Okay. And other than that, it will also enable better management of potential air emissions at central location, because if they have a good filter, they can control the gas emissions that come out from the incinerator. And last but not least, potential recovery energy from the heat release and valuable products that can be reused, recycled or marketed. Maybe they can focus on the energy recovery from whatever that maybe certain waste that have a high calorific value can be a fuel. Instead of using oil as fuel, they can use high waste that contain high calorific value as a fuel to burn the waste in incinerator. So the effectiveness of the treatment methodologies for organic hazardous waste, the priority is on the thermal, and then biological, chemical and also physical, because thermal always have the highest organic waste destruction, which is 99.999% compared to others. So incinerator is quite good in terms of volume. And then air pollution obviously is going to cause acid rain, which is not good, especially if we live in a city. Okay, one of the disposal method that we mentioned before is also composting. Because if we talk about recycle, we always focus on the plastic bottle, glass, and then cardboard, papers, and so on. But why we do not recycle our food waste? As the waste composition throughout all the countries, normally the most produced waste or generated waste are food waste, which is 40 to 60% compared to other types of waste. So the best way is to compose your organic waste or food waste. The definition of composting is very simple, is that the organic fraction of municipal solid waste, we are going to convert it into earthy, humus-like material by the action of worms, bacteria, and other microbes. We can also do it at home. So you can cater or you can tackle your own food waste at the kitchen, leftover from the cooking, and also leftover from your lunch, dinner, or breakfast. Okay, some of the countries have already realized the importance of the composting, because if we can reduce 40 to 60% of the food waste into the landfill, we are going to increase the lifespan of the landfill tremendously. So we should control on the food waste, because the food waste also, because of the biodegradability characteristic, is going to produce methane gases, and also the moisture is going to affect the digestibility of other types of material. So it is not good. So some of them have a composting advertisement and so on, just to create awareness on how important the composting process on the food waste. So there are many methods of composting. You can browse it online. Some of it are the backyard composting. You can do it at home. Just use a perforated drum composting, or 3-chambered bin composting, or circular bin composting. Just use a normal basket that you use for grocery shopping also could be used as the medium or as the location for the composting. So this is the bigger scale, normally at the landfill site. For example, turning windrow, aerated compost pile, and so on. Okay, the figure at the bottom that shown the backyard composting. So you should be careful. If you do it at home, you have to take care of your compost, because if you don't do it properly, your compost is going to end up like this, and it's going to invite flies, pests, rats, and so on. Okay. The process application of the composting of yard waste collected normally separately. We can compost organic fraction, and also compost partially processed commingled municipal solid waste, and also maybe we can co-compose it with wastewater sludge if we do not have enough bacteria. But issues in the implementation of composting is the production of odor. But we can prevent the odor issues if we do the steps correctly, and also public health issues or pathogen, heavy metals toxicity, and also product quality. Because normally if you do composting, you are going to end up with the organic fertilizer. You know that all the available chemical fertilizer, normally they have the proportion of the chemical to be put in to ensure the quality of the fertilizer. But if we do on the organic fertilizer, normally we cannot ensure on the quality, because it depends on whatever we eat and whatever we compose. This is one of the example of the home composting. We can do at home. And this is Prof. Takakura from Japan. He is introducing Takakura method, which is very simple. We can do it at home using a boxes or a basket, and all the ingredients needed are also available at our home. You can browse through, and you can also email me. I'm going to maybe guide you on how to do the Takakura home method composting. Okay, these are some of the Takakura method using a basket and also a composting medium, which is available in our kitchen. Okay, if you want to highlight the concept of the sustainability, if we talk about sustainability, we have to highlight few approach. We have to gather this approach as a whole on the environmental aspect, social aspect, and as well as economic aspect. Then we can tackle the sustainability as a whole. On these are the linkages of the Integrated Resource Recovery Center, IRRCS, in secondary cities and small towns of the Asia Pacific region. So this is actually, in New York, they have a General Assembly of the United Nations adopted 2030 Agenda for Sustainable Development as a global plan of action for people, planet, peace and prosperity. The 2030 Agenda contains 17 interrelated and indivisible sustainable development goals with 169 targets and 244 indicators. So this slide is showing on the solid waste. So we have to focus on the segregation waste at source. We have to do our part, which is to segregate or separate the waste at source. You have to separate the organic waste, recyclable waste, at least. If you are really keen on the recycling, you have to separate food waste, plastic, glass, paper, and so on and so forth, okay? And then they also want to improve the collection and disposal of waste. Maybe if we improve the collection system, on the recyclable, on the organic waste and so on, is going to be a better waste management system. And they also would like to enhance on the local capacity for solid waste management, maybe more financial going towards waste management will be allocated in the future. And then we have to establish very effective policies and also regulations and enforce it on the community or the producer or generator like us. And we have to develop low cost and locally appropriate solutions because nowadays they are focusing not only on reduce, reuse, recycle, but reduce, reuse, recycle, and also recovery. We should know whatever that we recycle, what is the end product that can come up with the things that we recycle. Okay, maybe a plastic bottle become a plastic bottle again, maybe a glass will become something else, so on and so forth. Okay, so if we have a clear vision of the recovery, maybe we are more aware and also keen to contribute to the recycling program. Last but not least is to raise awareness and also educate the use of 3R practices. So these are the IRRC approach. Okay, on the waste management, as I mentioned earlier, if we look at this figure, we are the waste generator. We generate waste in our daily life. So we are going to keep it in the plastic bag and then put it outside of our house, and then the waste collector and the waste management system is going to take care of the rest. If you look at the right figure, they have like this green show high priority, the yellow one show medium priority, and the red one show low priority. The green priority is on the waste reduction. It shows that it is very important for us to reduce the amount of waste that we generate in our daily life. How do you want to reduce the amount of waste? It is up to, or the responsibility of every single one of us. It is up to me, for me to reduce the amount of waste that I produce in my daily life. And also it is up to you, for you to reduce the amount of waste that you produce in your daily life. And another thing is that the green one or high priority is the landfill mining and reclamation. I think it is a global issues that we do not have the landfill site or certain area or available land for new landfill. So we have to play smart to do the landfill mining and also reclamation. We have to do recovery resource from old landfill to become a new landfill site. There are a lot of factors that affect the waste generation rates. Source reduction and also recycling activities. If you are active in recycling activities, obviously your waste generation rates is going to be reduced. And also your attitudes, as well as legislation by the government. The geographic, cultural, and physical factors also affecting how we generate our waste. So that's why at different places, normally the generation rates are quite differ per capita per day for each single one of us. When we talk about waste, normally we just say that total waste generated. So in total waste generated, actually in the house, we have the waste that we do not want. It will be labeled as the waste discarded. even though we do not want or we don't use it anymore, do we want to keep it as the waste retain to use it again? For example, old clothes. Do you want to use it again as maybe you want to wipe the house or whatnot, or maybe you want to recycle it, use it to generate a new bag or something else. So the waste discarded or the unwanted waste, whether you want to retain it in the house and use it again, or you want to dispose it straight away. Once you dispose, it's going to be waste disposed, where you put outside of your house and then will be collected by the waste collector. Okay. Okay, this is the traditional waste hierarchy versus the new waste management paradigm. I think previously we do not care about reuse, reduce, recycle, compose, transformation, and so on. We just focus on, okay, we are generating waste, and then that's it. Just put it outside of the house, and then someone will pick it up and then settle it to the landfill. You do not care as a person that generate the waste on where does your waste go. But now you have to change to the new waste management paradigm, which you have to emphasize, or you have to think carefully on the how to reduce and maybe come up with product design or producer responsibility. It's our responsibility to reduce the waste, to reuse it, recycle it, or maybe you have to practice compost on the organic waste, transformation, and last but not least to landfill. So we have to focus on all the steps before we dispose it outside of our house. That is our responsibility as the generator. We are all the generator, me and you. So actually there are many steps online that you can refer and so on and so forth. We can reduce the waste and there are so many methods. Some of it is that I think, okay, I choose one example. Purchase products in bulk or larger size. For example, why do we have to buy a water bottle which is for 500 ml? If you can buy a water bottle that consists of 1.5 liter of water. So you are going to reduce the number of the waste of the plastic waste because you buy the water in a larger size. The larger, the better, okay? And then concentrated products. Maybe you can come out, maybe you can buy the concentrated juice and make your own juice at home and bring it to the office or to the university instead of buy the juice from the water bottle and bring it one go and then just throw it away. So there are lots of things that you should maybe change in your lifestyle in order to reduce the number of the waste that you produce in your daily life. Okay, this is the example in Malaysia. We have these three different colors, which is blue for paper products, brown for glass, and orange for can and plastic products. This is just to motivate recycling with different colors of bin. I believe in other parts of the world, they have different promotions and also different motivation. We also have this recycling price so that all the consumers will feel motivated and also they want to recycle because they know that whatever they recycle, they are going to value it for money. So it's like waste to wealth, okay? The more you recycle, the more money that you're going to gain. But it is all manually. We do not have a machine or a specific system to do it, but we have to do it manually. Okay, I just want to share a little bit on some of the creativities that we can do if we have aluminum can. For example, we can do creativities in the kindergarten or maybe at the school so that we don't have to buy new things or utilize new things just to do these creativities. We can also use it as a maybe for stationery, decorations and so on. Plastic waste especially. Plastic waste, we can use it for decoration. For example, in this figure, it's Christmas time, so they use the recycled bottles to do the decorations. And some of the shops here, they even use it as the lights for the shops or stalls, just to make it colorful and also interesting. So why bother to buy a new one if we can use the recycled products to make a decoration? You just have to be creative. for paper and cardboard, we can use it for maybe a basket for stationery, other creative. As for the glass, you also have to be creative. We can do a lot of things, decorations and so on. And we also can grow plant in the glass waste. As for the tires, it's quite a lot, also in Malaysia. Normally in Malaysia, we do it as, we recycle it as a sitting area in front of our house, and normally we use it as a place to grow plant. And who knows, we can also use it in a fashion week. Why not? And for old clothes, maybe you don't need it anymore. You can give it to someone else. You can give it to your sisters, brothers, and maybe you can come up with something creative. You can create a bag, accessories, and props for others to be used. Okay, when we emerge from the creativity or recycling in a simple way, at the university level or at the construction level, they try to recycle it, especially in the developing countries. They have to use all the resources that they have to maintain their natural resources. So they are going to utilize any sources that they have from the waste stream to use it in the building materials. So what are the advantages of recycling waste in building materials? So this is on the serious note on the recycling that have scientific data and so on. The previously is just for fun and then we can do it at home, but this is on research base. I'm also in this area. So the advantages in recycling waste in building materials is that it's going to reduce the amount of waste sent to the landfill. It's going to conserve natural resources. This is what all the developing countries are trying to do. That's why they are trying to create new material. And then we can increase the economic security, prevents pollution, save energy, and also come up with an alternative low-cost, cheap materials, low-cost materials. Okay, we normally recycle it into bricks because it is quite flexible and because of the characteristic, it's quite durable. We also recycle it into concrete because we can see many interesting buildings are made out of concrete. But in terms of recycling in the building materials, you have to focus on these 4 aspects. I just want to focus on the number 3 is that in terms of the, obviously you have to meet the technical performance of the finished products in terms of physical and mechanical properties. This is the normal brick, this is the brick with the waste. The brick with the waste also have to comply with the physical and mechanical properties in terms of strength and so on. But the number 3 aspects is that the impact on human health and environment. Because we recycle waste inside of the building material, we must make sure that it is safe for us to use or to live in the building that is made from the waste material in terms of the leachability, the gas emissions, the compliance with the standards and so on, okay? So these are the leaching testing procedure. The leaching testing procedure normally for hazardous landfills, they are doing the same. Every single hazardous waste that you dispose at the incinerator or secure landfill, they have to go through the leaching testing procedure just to ensure that the toxicity level is compliant with the standards before they are being disposed or treated and also finally being disposed in the secure landfill. So when we try to recycle waste into building material, there are many factors affecting or controlling the leaching behavior of the heavy metals or the toxicity from the waste on the chemical as well as on the physical. So there's a lot of leaching testing procedure that we could use, and they have many references according to country, but the most common use is United States Environmental Protection Agency. Okay. A lot of testing, a lot of references according to countries and also region. And the leaching testing procedure that normally used is the toxicity characteristic leaching procedure and also the static precipitation leaching procedure. Okay, so they are going to use different acid and also different time and also different sample. TCLP and SPLP using crushed samples, SLT using solid sample. So the simulated weathering also differ, the time also differ. Okay, so these are the steps on to do the testings, and these are the permissible limit of heavy metals according to US EPA, EPAV, WHO, and so on. Just to ensure that the heavy metals is compliant with the standard, so that the building material built from the mixture of the waste and also the raw material is safe to be used. And also the gas emission. Whenever we fire the fire clay brick, for example, the brick incorporated with waste, normally the gas emission also will be detected. We just want to ensure that whatever waste that we put in is going to be safe in terms of the emission, in terms of the leaching, and so on and so forth, so that the consumer will feel comfortable living in it. Okay, I'm just sharing some of the studies that I did on the sludge waste issues. There are a lot of 105 tons that being produced in Malaysia. So I incorporated sludge into brick, and it is successfully and also comply with standards, because the sludge contain very high heavy metals. But the good way is that it is able to be incorporated in brick and also comply with the standards, and also complying with the physical and mechanical properties. We also have university industry partnership, because this is what industry wants now. They have the waste, they want to use it, but they do not know how. So we help and assist them on how to make profit out of their waste, not spending money to dispose the waste. Okay, on the sewage sludge bricks, sewage sludge, and then we also recycle it into building material. The number is quite high, which is 5.3 million per year, and it is also successfully being conducted. Okay, the agricultural waste issues also quite high in Malaysia, because we have palm oil mill, because we are the second largest producer. So we have this a lot of agricultural waste issues. So we also managed to recycle it into building materials. And during my study, I did my PhD in Melbourne. It is stated that 7 years in a row during summer, they try to pick up all the littered item on the road, and cigarette butt is the #1 most littered items in Victoria or in all around Australia. So they think they have to do something about it. So I recycle cigarette butts into fired clay brick. We know that cigarette butts have like more than 40 toxicity, concentrated toxicity inside the butt, because it traps whatever that we smoke in, and eventually we try to recycle it and it complies with the standard. So we are going to save money in terms of disposing all this waste, and we are making profit out of it. But we have to use it carefully, and we have to know how to play around with this waste. Another waste that we try to recycle is fly ash and bottom ash, which is 100 to 200 million tons per year, the production. So we recycle it into concrete, and it is able to be put up to 30% in self-compaction concrete, and comply with the requirements in terms of physical mechanical properties as well as the leaching. Okay, that is on the recycling. And then we move on to the case studies. We have to learn from the best countries on how they manage their waste. So we have this one global waste index that offers a comprehensive breakdown of the most environmental friendly methods of waste management. It ranks the 36 countries within the Organization for Economic Cooperation and Development, OECD. So we do not want to look at the top 3 worst at managing waste, but we are going to learn from the top 3 best at managing their waste. So #1 is South Korea. How do South Korea did it? They also facing the same problem with us. In 1960s and 70s, they are focusing on the waste collection, and then 1980s waste treatment, 1990, waste reduction and recycle. 2000, they are focusing on the circular economy. Circular economy is on the reduce, reuse, recycle, and recovery. So I think the South Korea has a highly organized waste management system known as Jongyangje. I think the best part is when they introduce the volume-based waste fee VBWF system, which is pay as you throw waste management. We have to pay to throw the waste, especially on the food waste. So they managed to ban the food waste from going to the landfill. And also they implement the radio frequency identification, which is RFID, on the food waste management system. Okay, they have a clear route for every single waste. For example, food waste, recycling materials, municipal solid waste, where do all the waste go? They have the clear route of that. And then they also have the volume-based trash bags for food waste. They save like 95% of they manage to recycle 95% of the food waste. So what the success story of the South Korea is that the system led to 17.8 reduction in municipal solid waste generation and 21% increase in recyclable waste. And also they increased the recycling rate from 15.7 to 43% in 2001. And the current recycling rate is 59%, which is quite huge. They also have this RFID food waste disposal system. The automated bins equipped with scales and RFID weigh the food waste as it is deposited and charge residents using an ID card. So you have to pay as you throw the waste. And they also have this reverse vending machine that you can put all the maybe plastic, bottles and so on, so that you're going to get money out of it. Okay, number 2 best country is Sweden. Sweden managed to change from every person recycle only 40 pounds. Now every person recycle average 357 pounds. And they managed to reduce the number of waste from 6.6 pounds only to the landfill from 430 pounds. I think the reduction is quite significant. Okay, they are focusing the recycling on the aluminum cans and PET bottles because they know that aluminum cans and PET bottles is the most common waste that we normally use and recycle. So they are focusing on these two. And the equivalent to 1.8 billion cans and bottles, or average 177 per person per year. So they managed to recycle almost 85%. Okay, and they will give money for 1 can and small bottle is 1 krona and 2 krona for large bottles. So waste to wealth. You recycle waste, you get the money. So now where 35,000 tons of material is recycled and turned into new bottles every single year. So they recycle a bottle to turn into a bottle. And all the household garbage from nearly 10 million residents, they convert it into electricity and supply heating demand of 1.25 million apartments and electricity for 680,000 homes. So they do not have to pay for the electricity because they can recycle the household garbage into supplying the heating demand of 1.25 million apartments, which is quite amazing for me. So case study recycling in Sweden. In Sweden, they have this like supermarket magic machine. It's like a reverse vending machine, the same concept. So you hand something in and you get money in return. You put the recycled item, you get the money. So it is first introduced in 1984. So I think most of the developed countries are trying to shift on that side of technology. Okay. So in 2015, the country recycled 1.4 million tons of waste, and now they are aimed to recycle 100% and also come up with renewable energy by 2040 with zero gas emission by 2045, which is quite amazing for Sweden. So these are the reverse vending machine and all sorts of recycling facilities that they provided in Sweden. Okay, last but not least, in Japan, they also have gone through a few processes until in 2000, they really sorted all the reduce, reuse, recycle, and also recovery seriously. How is it started? Because of the Minamata disease, that due to the mercury poisoning that released from the factories, then they take the waste seriously. So they have so many acts that they develop due to that, so that all the legal system is establishing the Japan as a material recycle society. And if you look at all the guidelines in waste management Japan, every single city have their own guidelines, have their own booklet on how they should recycle their waste, which day that they should recycle plastic waste, with what color of plastics, and then which day they should recycle bottle glass waste, and what color of plastics. They have all the rules stated in the booklet and also the guidelines. And every city have their own guidelines and also booklet on how they should recycle. So, but if you see from this slide, it is quite clear on how to tackle every single waste that we should recycle, which is good. Okay, if you have bottle, you have to take it out, you have to wash it, you have to take off the label and so on. Even the label, the cap, the plastic inside, you have to separate properly. And amazingly, I think Japan, they really become a material society, recycle society, because they follow the rules obediently, okay? So they also have the same reverse vending machine that turn trash into rewards. I think that's all my sharing for today. Thank you for listening. I hope you enjoy listening to my talk, and thank you so much.
Yeah, thank you so much, Dr. Aslina, for your interesting presentation.
Okay.
Not sure. Let's see if there is any question. So please, for the participants, if you have any question, you can type it in the chat box, and please try to be specific so that we can, that Dr. Aslina can respond to your points. So is there any question? Somebody is asking how can we start recycling?
Oh, you can start recycling by first separating your waste at source or at your home. So you can separate organic waste and also recyclable item. More appropriately, you also separate plastic, glass, rubber, and so on.
Sorry, can you please mute the mics because we see a lot of noise.
Dr. Wesam, I already unmute all. If there are any question, they can raise hand and directly dialogue to speaker. You can manage who will rise up and then.
Dr. Wesam, there's one question for me. Is it okay?
Yes.
Because there's
I'm sorry, Dr. May. Can you please, for the participants, can you please mute yourself because you cause some noises and we can't, the panelists can't respond to your questions. So unless for those who will ask later on, please keep the mics muted. Okay, Dr. Maya.
Okay, thank you so much. Can you build the greywater treatment? Is it possible to implement in the rural area? So my suggestion would be that you can use a local waste material that I showed in my presentation, for example, some clamshell, ceramic, okay, gravel, and then the greywater that you are treated, you can use it for irrigation. So you can save money. So I don't have cost that I can say to build the greywater treatment, but this can be doable by using your local waste materials. I hope that this is answer. Yeah, thank you.
Okay, for those who would like to ask and those who raise their hands.
Yeah. Good morning.
Good morning.
Hello.
Dr. Achib, can you?
Okay, so it's better I unmute everyone.
Yes, yes. We just will take the question from the chat box.
Okay, okay, I understand. Okay.
Thank you. Thank you. So there is one question: how we can manage the waste management process in rural areas where people are unaware and unknown. So this is maybe for Dr. Aslina.
Okay, maybe for the rural area, maybe you have to collect the waste properly. If you can manage to do compost, you can do compost at home. And then if you recycle or you separate your waste from home, you can pass it to the recycle system. And I believe you are going to end up with very little amount of waste that you have to dispose at your own home. I think there's one question. They said, is it possible for an individual to start a recycling company? I think it is possible, but I'm not sure whether the return investment is going to be a quick one or maybe it's a long-term one. Because normally recycling business is not that profitable, but it is more towards saving the environment. But if you manage it properly, you can always make waste to wealth. It says from Amar, don't we need to put limitation on the productions of plastic materials? Is recycling going to be enough? Yes, I think maybe we should come up with biodegradable plastic materials. And for the current situation, the best way is to recycle, and maybe we have to be very specific. For example, the plastic bottle produced from Coca-Cola have to be recycled by Coca-Cola to produce another plastic bottle for the usage of the Coca-Cola company. So it's going to close the recycle loop. I think that is the best way if we still want to produce plastic materials. But if we can come up with biodegradable plastic materials, that is the best. Or maybe we do not come up with any plastic materials at all. But it is quite impossible because we already used to it. We can't live without plastic bags or plastic.
Okay, there is one question for me about how we can make the on-site wastewater treatment for the small micro enterprise that generate huge wastewater in their premises. My suggestion would be is either you can just do some treatment like a sedimentation pond, or maybe you can use some wetland system if you have the land space. And you can use certain local materials that can enhance the biodegradable organic matter by the microbes. You can. And if your industry deal with this, for example, manure, waste, food waste, even food waste, you can try to use anaerobic digester so that it can generate the energy from it. Yeah, that's my suggestion. Okay.
And then one of the audience said that you like what the Rwandan government has done on banning use of plastics as carry bags to paper envelopes. Actually, Malaysia also in 2030, they are going to towards the zero plastic bag in Malaysia, for example. And we are trying moving towards that direction, but I think it's going to be a very long and hard fight because we all are really used to having plastics around, but it is going to be, I think we can make it happen if we do it together, because it's not from a single person. We have to do it as a community. And it has been done in a small city in UK. They have successfully replaced everything. They do not have any plastic usage at all in that particular city.
Okay, there's a question from Sam about how we can introduce the Greywater concept when our local governments are not viable to support the scheme. I think if you're using your river water as a main water supply, this is a very much concern by the local government that you should do, because greywater cannot be discharged directly into the waterways. If you have the centralized system, it can save our water body. So I think this you need to be give some information that this should be done, okay, to the local governments, okay, because there is a lot of the effects to the environment and also the human health if we disregard the importance of the greywater management.
One of the questions said that, what is your recommendation for countries that are not yet involved into effective waste management system? I think we have many constraints actually in terms of the cost and also fund available, and also there's a lot of factors that I mentioned previously, the awareness, lack of demonstrated, ineffective policies and regulations, and so on. I think the best way is we have to work on one factor at one time, because we are all developing countries. We are not like developed countries. They have all the fund and also sufficient local capacity and also resources that will be good for them to maybe implement it right away, and they have successfully doing it. But in terms of the developing countries like us, I think we have to take one step at a time. Small steps normally will last a long way. So we should do something about it and try to improve from time to time. There's one question on how to deal with hazardous waste or chemical waste. So hazardous waste and chemical waste in Malaysia, we have, I think all other countries are the same. It is under the schedule waste. So we can't just dispose it on the normal landfill. We have to follow the schedule, and also they will be collected accordingly, and also they will be disposed in the incinerator. They treated the waste first and then burn it, and also they will test for leaching test to make sure all the leaching toxicity is compliant with the standards, and in the end they are going to dispose it in the secure landfill, which is specifically for hazardous waste and also chemical waste. and it is the requirement of the secure landfill is more strict compared to the sanitary landfill. So we can't just put hazardous waste and chemical waste inside the any landfill, sanitary landfill, landfill level 1, 2, 3 or 4, no. We have to dispose it in the incinerator or secure landfill only. Okay, one of the questions, it says that the generation of plastic waste has become so huge in our country that during every raining season, it blocks drainages, gutters, causes flooding and pollution of seas and beaches. Can you help us with some immediate advisable solutions? So I think one of the best solutions is that we have to play our role. Maybe the best way is to collect all the waste that clogging or blocking the drainage. Even in Australia, all over Australia, they are going to have the summer activities which to collect every single little item on the road, and they just going to rank it. For example, the first is cigarette butt, second is bubble gum, the third one is plastic, and so on and so forth. So maybe it's going to be activities in the city or in that particular area just to collect all the plastic bottles that been clogging and also blocking the way. But it takes the whole community to cooperate, and it is our responsibility to do it.
So we have lots of questions here. I think I can pick only the relevant one regarding to my expertise. For example, here, how we can use water from river without any treatment for drinking purpose. Whatever it is, I think you need to boil the water for the safe consumption before you use for the drinking. Yeah, and then the rest is there's a village, they use the water from river without any treatment for drinking purpose. So I think it's the same, yeah, for previous one. Maybe you can use some pre-treatment filtration before you can use it, and then make sure that to avoid some contamination, you need to boil the water. I think that's all for me, Dr. Wisam.
Yeah, okay.
They
So,
can if they need some questions or research and whatsoever, me and Dr. Aslina.
okay, so thank you so much for Dr. Maya and Dr. Aslina. I think we conclude the session here. Dr. Achib, are you there?
Yeah, okay.
So maybe, do you have any concluding remarks?
No. Maybe from you, just information for tomorrow. We still continue.
Yes, yeah. So we'll see you tomorrow for the next session on economic sustainability.
Yeah.
And also there will be another session. So we'll have 2 slots tomorrow, one on economic sustainability and other on the green business concepts. So thank you so much for your attendance today. And thanks for Dr. Maya again and Dr. Aslina for giving these wonderful presentations. And thanks for Dr. Achib for the arrangements. And we'll see you tomorrow again.
Yes,
Thank you
tomorrow.
so much.
Very interesting topic as well for economic, and today also very interesting. Every day very interesting. Thank you very much.
Yeah, thank you so much.
Okay, everyone. I hope that this benefit to all the sharing session. Thank you.
Yeah, thank you so much.
Everyone for listening.
Thank you.